Hi, it's Ms. Richmond. You've been working on solving systems of equations. Today we're going to work on setting up a system of equations from word problems. Specifically, we'll look at quantity value problems, as I call them. Just a reminder before we start. In general, for word problems, remember to use our less so that you get more points. Less means write your let statements, your equations, solve the equations, and then be sure to write a sentence answering the question. Today, as I said, we'll just focus on writing the let statements and the equations to develop the system. We'll assume that from there you already know how to solve them and can write the sentence. Here we go. The first one. The library is having a book sale to raise money. Hardcover books are $4 each. Paperback books are $2 each. Ms. Richmond spends $26 for 8 books. How many of each did she buy? So the first thing we need to do is write our let statements. So I'm looking for the number of each kind that Ms. Richmond bought. So I would say let X equal the number of hardcover books, and I could say let Y equal the number of paperback books. Okay, and then after that I'm ready to write the equations. So I know hardcovers are $4 each, paperbacks are $2 each, and spending $26 for 8 books. That means I buy 8 books in total. So the first equation that comes to my mind is that if I add the number of hardcover and the number of paperback books, I should get 8 for the 8 books. So that means X plus Y would equal 8. Secondly, if I look at the dollar amounts, the hardcovers are $4 and the paperback books are $2. So how much do I spend on hardcover books? Well, if they're $4 each and I buy X of them, that means I will have spent 4X. And on the paperbacks, those are $2 each, and I buy Y of them. So that would be plus 2Y, and that should equal the total amount I spent, or $26. So now we've written the equation for the system of equations, and you know how to solve that either by elimination or by substitution. Let's go on to our next problem. Okay, this is similar. The restaurant sells 2 sizes of drinks. Julia buys 3 small and 5 large drinks and pays $28.20. Ryan buys 4 small and 5 large drinks and pays $23.30. How much does the large drink cost? Well, obviously we have both small and large drinks happening here, so my variables need to incorporate both of those. So I could set those up as let S equal, and I'm looking at the cost of the drinks, not the number of drinks. So I need to specify that. So S would be the cost of the small drink. And maybe I would put for the large one L. So let L equal the cost of the large drink. Okay, so now if I look at the information I have to write the equation, I know that Julia buys 3 small and 5 large drinks. So how much does she, and she pays $28.20. So for the small drinks, that would cost her 3, because there are 3 of them, times the cost of the small drink. So that would be 3S. And the large drink would cost her 5 times the cost of the large drink, so that would be 5L. And if I add those, the cost of the small drink with the cost of the large drink, I should get the total that she paid, or $28.20. So I need to add those, and it should equal $28.20. Okay, and then for Ryan, he buys 4 of the small ones and 5 of the large ones. So similarly, his would be 4 times the cost of the small drink plus 5 times the cost of the large drink, and that would equal $23.30. And so now I have 2 equations, 2 variables, and you can see that since they both have 5 large drinks, this is all set up for elimination by just subtracting the 2 equations. Let's move on to our final equation for this video, our final problem. So this is a coin problem. And coin problems are all very similar. You have a certain number of coins, and they tell you what kind of coins they are, and then they tell you the total value. And you're looking for how many of each coin you would have. So in this case, 23 coins, all nickels and dimes. We want to know how many of each. So I could say, nickels, I want to know how many nickels. So that would be let n equal the number of nickels. And I also have dimes. So for the dimes, I could use D. Of course, you can use X and Y if you want, but I find it easier to use something that helps me remember as I'm doing the problem what the variable stands for. So now I know I have 23 coins. So the number of nickels and the number of dimes must be 23. So that equation can be represented by n plus d equals 23. Oops, didn't do a good job typing that. Let's try again. So n plus d equals 23. And the total value of the coins is $2.05. So I need to think about how I get the value of the coins. Well, if I have n nickels and each one of them is 5 cents, I have a choice. I can either do everything in the problem in cents, or I can do everything in terms of dollars. So let's do everything in terms of cents. I generally find that's a little easier. So how much do I have in nickels? Well, I've got n of them, and each one of them is worth 5 cents. So altogether, they must be worth 5 cents times the number of nickels I have. That's 5n. And then the dimes, how much are they worth? Well, they must be worth, I have D dimes, each one of them is worth 10 cents. So that would be worth 10 cents times the number of dimes. And if I add those two together, so I'm adding the amount I have in nickels with the amount I have in dimes, that should give me the total amount of money I have, which in this case would be $2.05. But I need to put everything in cents. So I need to write it as 205 because it's 205 cents. The other way I could write this, of course, would be to do everything in dollars, and then I would have, instead I'd have 0.05n plus 0.10d equals 2.05. But then I'd just want to clear my decimals and I'd get back here anyway. So I think that it's much easier to do everything in cents the first time through. So I'll erase this. So my two equations for my system, the number of nickels plus the number of dimes is 23 because I have 23 coins. And the value is $2.05. That's 205 cents. So 5 times the number of nickels plus 10 times the number of dimes. And there's